Alright, so now let's take a look at the rules of interference. So what are the rules of interference? They're basically just a set of valid arguments. All of these little arguments here are valid, okay? And they're used to show that a conclusion logically follows the premises. So say you had a set of premises and you wanted to show that they do in fact lead to a conclusion, then you use these rules of interference. Since these are all valid as well, if you can successfully show that all your premises lead to the conclusion, you also know that your statement is also a valid statement. So here I've listed out all of the different statements, and just take a moment to go and memorize them, because that's the easiest way to look to know about them, and then you can then use them in real life applications. So let's go over an example right now, actually. Okay, I have my premises here, not P and Q, R or S, and then R implies P. And I want to show that all of these statements together imply that S is the conclusion. Okay? So let's start off here by looking at our first premise, not P and Q. So we can go back to our rules of interference here, right? And we can see that there is something that we can do with these rules to basically simplify this down. So right here, let's look at our simplification rule. This is just a general form for it. So say we wanted to use this on here, on this premise right here. We see that we have a not P and a Q. Well, which one would probably be the most use to us? Well, we can see here we have a P right here, so I guess a not P would be the most useful to us. So let's simplify this down to a not P. So I did a simplification right there. Okay, so now, since we got this not P specifically so we could use it on this R implies P statement, let's use it there. So we have our not R implies P premise. Now let's go back up here. What is something that we can use here to simplify this down more? Well, I see that I have a P and a not P, right? And we have a rule right here that we can use to help us get this down to something just to R, or not R, sorry. It's called the Modus Tollens rule. And here you can see when you have a not Q and a Q and a P implies the Q, this will simplify down to not P. So right here we can apply that to this set of premises, and we can say that not P when it's combined with R implies P, it reduces down to not R. And that's a Modus Tollens on it. Okay, so now finally we're almost done, and our last premise that we have to use here is R or S. So what's a rule that we can use where we have a not R and then also a statement, or we have a not something and then a R or S, or P or S, whatever you want to call it. So we have to find a general rule for that. And the rule we're going to use here is the disjunctive syllogism rule. And you can see here that when you have a P or Q combined with a not P, you get a Q. So right here we can use the disjunctive syllogism, and right here this becomes S through a disjunctive syllogism. And there you go. We've shown that this statement is valid because it logically follows these premises.